Okay, so we're starting with our bell ringer on worksheet 4A. We're just going to do the side 4A today. First of all, the problem says that Stephanie interviewed 142 random students in each grade at her school. Is this sample of students at her school likely to be biased? Why or why not? Okay, so it does give us the answer here. Clearly, it says no, she divided the students into groups by grades. It's a representative sample. So the things that we need to remember, what type of, with interviewed people, was this a survey, observational study, or an experiment? Okay, so this was a survey. So the points that we need to remember about a survey is the groups need to be equal, needs to have equal groups. And you can write this in any wording that you want. My pen's sticking on me. Okay, and they need to be representative of the population. Right? Okay, so you also need to use unbiased questions. If you're using a survey. So you want to divide, we discussed types of things to avoid as far as the questions go. And the other thing about picking your groups, everyone must be equally likely to be chosen. Okay, so those are just little reminders of what we need to do if we're doing a survey to do it properly. Okay, so we got a few scenarios following up here. Anybody need this still? Wait a second. Okay. Right, Red puts names of all the cities in the state into a jar and then drew 12 names out of the jar. Is this sample of cities in the state likely to be biased? Does that sound like you'd get a biased sampling? No. Okay, good. No. They all have been randomly chosen. Okay. And each is equally likely to be chosen. Each city is equally likely to be picked, whatever wording you want to use. Okay, let's think about this next one. Oh, we have two Matts in here. Matt bought 3 pairs of socks in each athletic store in the mall. He bought them at each athletic store in the mall. Is this sample of the socks sold at the mall likely to be biased? Now, is that why or why not? Anyone? Olivia? Absolutely. Okay. So they are biased. This is biased. What do you want to? How did you word that again? I would like to go ahead with your wording. Okay, they only picked from athletic stores. So what are you saying about that? Okay, great. Other stores in the mall sell socks. Okay. Do you know of other stores in the mall that sell socks besides athletic stores in the mall? Okay. Well, we're going a little too far with it, Madison. You're taking a little too far. It's not like just an athletic mall. Okay. Okay. I've never been to a mall that doesn't have other stores that sell athletic socks, so we're going to assume it's just your average mall. And I know if I went to our mall, Cherry Valley, that you're going to be able to get socks at Macy's and Bergner's and a lot of other places. Okay. Katie interviewed 13 of the most experienced teachers at her school for a paper. Is this sample of teachers at her school likely to be biased? Okay. Max. Okay. She did not choose from all the teachers, right? Okay, so that's definitely biased. All right, now at this time, you can set that packet aside and let's grab the new one we got off the podium when you came in. We're going to look at worksheet 12A. We'll see how far we can get today. The probability of an event, this is about conditional probability. We have talked some about it. This just has a different formula that we're going to give, but I'm going to again tell you that you're going to want to approach the probability questions most of the time in the most common sense way possible. Okay, the probability of an event, given that another event has occurred, okay, so something else has already happened, the probability of that first event happening given that something else has happened is called conditional probability. The conditional probability that event B occurs, given that event A has already occurred, can be represented by this notation. So that's all that is saying. That notation is simply saying the probability of B given A. So you might want to note in words what that means. Given A has happened or occurred. Now, I would like to approach the next problem and show you that there's a couple of mistakes. This actually came from a text, and I found a little bit, oh, this one doesn't have the problems. It's another place on here. But we're going to do this with a more common sense approach than what this is showing us to do. This looks way more complicated than what we've already discussed on a different day. So, it says, Naomi is playing a game with the spinner shown. What's the probability that the spinner lands on a 7, given that Naomi has spun a number greater than 5? So if we look at that spinner, how many numbers are bigger than 5 on it? Okay, so what do we really need to pay attention to is the numbers bigger than 5. Okay, they said she spun a number bigger than 5. What's the probability that she actually spun the spinner lands on a 7? Okay, so we've got 3 numbers to choose from because those are the numbers bigger than 5. And she landed on 7. There's only one 7. So that's why the probability would be 1 in 3. Now, in a statistics class, they like to show you a lot of formulas, and I can show you too, because that's basically what we're doing, is doing an introductory probability chapter. They would give you this lovely formula that says the probability of A and B divided by the probability of A. That's the conditional probability formula. I think it's much easier, the way we've discussed it, is to say, look at the last part. Okay, so what we're doing is the probability of spinning of 7, given that the spin is greater than 5, is look at the part that's given and then find the probability of doing the first thing. Okay, so we'll do some examples to try to understand where all that comes from. Now, again, I'm showing you a deck of cards again because I know some students aren't that familiar with cards. So just a reminder, we're going to do quite a few questions today that have cards involved. And so we have 8 clubs. These are the diamonds. The next suit is the spades here. And The next suit is called hearts. There are 13 of each suit. And there are apparently 2 black suits, right? And 2 red. So half the cards are black, half the cards are red. Just a few things to keep in mind. So there are 4 of each type of card as well. So cards are drawn from a standard deck of 52 cards. Find each probability. The card is a heart, given that an ace is drawn. All right, so what part do we need to look at first? This is what I want you to think about first. Okay, that's going to be your denominator. And then the probability, the card being a heart is going to be the numerator of our probability. All right, so I'm not going to highlight everything like this because we'll start to get the hang of this pretty fast. How many cards are an ace in the deck? Jeremy, 4? Okay. There are 4 cards that are aces. That's going to be your denominator. How many cards are hearts that are aces? There's only 1 of them. Okay, one of the cards that is a heart one of the cards that is an ace is a heart. So 1 in 4 is your probability of getting that. All right, so again, the next one is about cards as well. The card is the 6 of clubs, given that a club is drawn. So we want to think first, how many cards are clubs? 13. How many of them are 6s? 1. So 1 card in those 13 cards is a club and a 6. Okay. Probability that a card is a spade, given that a black card is drawn. So now we want to think about how many black cards there are in all. And that would be 13 plus 13. Okay, 26 of them. And then what's the probability that it's a spade? Oh, that's 13 out of that. And this reduces, you might have already known it was 1/2. Half the black cards are spades. All right, the next part is about a die, and we should know that the numbers on a die, of course, are 1, 2, 3, 4, 5, or 6. There's only 6 faces because it's a cube. What's the probability a 4 is rolled, given that the roll is even? So first thing we want to think, how many numbers are even? 3, 2, 4, and 6. And how many of them are the number 4? Only 1, so 1 and 3. What's the probability a 2 is rolled, given that the roll is less than 6? So how many numbers are less than 6? All right, 5. And then the probability that a 2 is rolled would be 1 of those out of 5. Number 6, probability that an even number is rolled, given that the roll is a 3 or a 4. I'll let you get that one, Jada. Come on. Probability that it's even if it's got to be a 3 or a 4. 1 out of, you only have 2 choices. 1 out of 2. Sorry, I didn't mean to put you on the spot. Okay, now you have obviously flipping the page. This is a table called a contingency table. It's a table that records data in which different possible situations result in different possible outcomes. We've actually made a couple of those tables when we did some things. We were asked a bunch of questions about freshmen and sophomores and female and males and all that. And I thought organizing in a table was a good idea. This one says, find the probability that a student plays lacrosse given the student is a junior. All right, so who are we looking at? It says they have to be a junior. So we're looking at the juniors. All right, and now it says the probability that a person plays lacrosse, given that they are a junior, we're going to figure out how many people play lacrosse. That would go from that column. So there are 34 of the juniors playing lacrosse. Now here's the common mistake. You can't just take these 2 numbers and think you're comparing them. You got to think about it. How many juniors are there? Is that listed in this table? No. So let's figure that out. 34 plus 510. Okay, we got 544 juniors. I'm approaching this problem a little differently than they did because they're using that icky formula. There are 34 juniors out of that play lacrosse out of 544 total juniors. Now remember how to reduce on your calculator because there's an error on this page. Grab your calculator. Guys, everybody got a calculator out? Reminder. You need one. We got some big numbers we're going to have to do some reducing on. Okay, so we're going to type in the fraction. My pen keeps not stalling on me. 34 divided by 544, I believe. Yes. All right, now we want to reduce that, so we're going to use the math enter button because when our numbers get really big, it's not so obvious what it reduces to by hand. We got 1 and 16. You see a mistake on this page? I see a couple of them. This again was printed straight from a book. First of all, if they were adding up the freshmen and the sophomores and the juniors and the seniors, there's a boo-boo right here. Either this has got to be 14 or it's 17. So that chart needs a 14 right there. I just would rather you don't have anything wrong on your paper. And then we just reduced our fraction, and our calculator told us it's not 1 and 6, it was 1 and 16, but then down here the answer says it's 1 and 16. So anyway, we've got it all fixed now. We didn't really even need this total of all the students was 2,180 to do that particular question. So within the questions, you're going to have to decide what it is you need to total up and figure out, because we might have needed to find out how many people played lacrosse. It depends on the question. So sometimes you're going to have to do some totaling. All right, so let's try another example using a contingency table. We're going to figure out what we actually need to total up to get the answer that we need. So it says weddings. The table shows attendance at a wedding. Find the probability that a person can attend the wedding given that the person is in the bride's family. So we need to pay attention to the bride's family, not the groom's right now. All right, there's the bride's family. How many people are in her family? 104. Come on, guys. 136. Thank you, Allison. All right, find the probability the person can attend. How many of those people can attend? 104. Okay, so we got 104 people that can attend out of 136 in the bride's family. Please reduce that. I'll type again 104 divided by 136. Math, enter. Okay, and getting 13 over 17. And that would be our answer. All right, I'd like you to try the next one, please. All right, do I have a volunteer? Tell me what I should look at. All right, Matt. Okay. Okay, so Matt just told me that he looked at, so everybody could hear, given that there's a senior, so we're going to look at seniors. Okay, We need to know how many seniors there are here. 340. Good job. Now, it said, what else? Find the probability that they play baseball. All right. So I bet I saw some people already with this answer. 34 out of 340, and they had this reduced to 1 in 10. Okay, good job. All right, number 3. We got a shopper using, oh, and now we got a whole different set of stuff. We got some stores. We've got cash, credit, or debit. I'm sure people look at this kind of statistics in their real businesses. So, let's see what we want. A shopper uses a credit card given that the shopper is shopping at Jacob's Gas. All right, where's Jacob's Gas? That's all we're going to look at. Can you guys start pulling, please? Oh my goodness. Now, I did total some of these already. Well, how much? 1,140. Thank you. All right, and then it says the shopper uses a credit card given that they're at Jacob's Gas. So we want to look at the people that are using a credit card. So that'll be the 456. $456 divided by, was that 1140, please? Did I remember that number correctly? Thank you. All right, 2/5. All right, try B and C, please, and be careful on C. Okay. This one was shopping at Pet Town. Now, I saw almost all the right answers for Part B. So let's see if anybody needs me to explain further that this one was 28 out of 147. Okay, and I saw almost everybody had this reduced to 4/21. Okay, questions about B? All right, this is the one you might have had boo-boos on. I was looking around. So let's be careful and make sure you're paying attention to how you should have done the last one. The shopper is shopping at TJ's given that the shopper is paying cash. This one's not vertical like the last two. This one's horizontal. I'm going to erase that. We can actually see this number. It says a shopper is shopping at TJ's. We need to find out how many people are paying cash. We've got to add up all these across. Okay, so I get 595. How many of you actually had done that, gone across that way? Oh, awesome. Perfect. All right, very good. All right, so you got 595. And then shopping at TJ's was 102. And the reason I was, I noticed that before when I've done this particular question that in the last hour, a lot of people had not thought about going horizontally. They were trying to do it vertically again, and I don't know what they were doing, but we just figured out you guys were getting it. All right, perfect. So let's go 102. That reduced to 6 out of 35. All right, now your assignment, a part of your assignment is going to be page 761, 762. So please make note of that this has been assigned. All right, it is not all we're doing. We are going to do part of 14 at least. So if you would turn to 14, 13 is going to be assigned later, actually tomorrow. We'll add that into the mix, but you're going to get some work time tomorrow. All right, so please go to page 14. There is no way I'm going to get 14 and 15 in, which was a whole plan, but otherwise I'm going to have to really speed through, so I'm not going to do that. So we'll just see where we get to. Now, we've already, again, talked somewhat about independent and dependent events. Possibilities of two events are either independent or dependent. If the occurrence of one event doesn't affect the other, then they are dependent. So this is a blank you need to fill in on your worksheet there. Two events are dependent if the occurrence of one event does not affect the occurrence of the other. Two events are independent if the occurrence of one event, did I just put that backwards? Holy crumbly, I can't believe it, and you caught me. They are independent if one does not affect the other. I don't know what the heck went in my brain. They're dependent if, it must be too late in the day. Sorry, guys. Two events are dependent if the occurrence of one does affect the other. I mean, that just makes common sense. But I put it in the wrong place. My apologies. All right, I don't want to read all of these to you, first of all, but I want to discuss with you just a few of the examples that are in here, and we are going to do a couple of them together that the answers aren't there for. So this is basically, oh, hold on a second. Did I skip something there? This is 14A. All right, only thing I need to remind you further on this page is what this means again. Where'd it go? Nope. So you know what this little notation is. When it says P of B/A, again, a reminder that that means the probability of B given A has occurred. Given that A has already occurred. Most of the questions, though, you're going to be able to tell. Anyway. And we wrote that down. Right. So yeah, that's all. I didn't want to just read the rest of that stuff to you. You can read it over some more if you'd like a little more clarification, or if you just want to do some light reading on probability, which I doubt you do. All right, 14B, let's get on there right away. We get some more examples in. All right, now this is explained here somewhat, but I want to go through it with you and show you where they got these answers. So if you saw this spinner, it says, find the probability that you get a 25 on your first spin and a 50 on your second. All right, so you would have to obviously look at the spinner and see that there are 25s on that spinner. And there are 8 separate slots that you can spin. So the probability of getting 25 on the first spin would be 2 out of 8. All right. When you're doing the probability of one event and then the probability of another event in combination with it, you multiply. Remember we did ORs, that was when we added. This is when you multiply. So the first spin, you got a 2 out of 8 chance of getting a 25. The probability of getting a 50 on your second spin then is, how many 50s are on there? 1 out of 8. So you multiply the two probabilities and you get 2 out of 64. And then you reduce. And that would be 1 in 32. Now, if you were to type on your calculator 1 divided by 32, you could turn that into a percentage, and that's the other thing about their answer there. It'd be 0.03, you move the decimal 2 places, it's about 3.1%. And that's where this came from, down here, 3.1%. Sometimes you want to look at it as a percentage. Good. Find the probability of dependent events. Okay, now, if you're taking a bowl of 36 green grapes and 14 purple grapes, you randomly choose a grape and you eat it, and you randomly choose another grape, find the probability that both events A and B will occur. Now, these are dependent on each other. What happens the first time you eat it, you're going to eat one of them, so you're going to have less grapes to choose from. All right, so the first event A, first grape is green, the second grape is green. I'm just going to do this with you. So how many grapes do we have in all? 50? Okay. To get a green grape on the first try, you're going to do 36 out of 50. Times now you ate it. So how many green grapes are left? And how many grapes are left though? 49 out of in all. And so you have to multiply those two probabilities. The numbers get rather large and then reduce. So again, how do you type that? 36 divided by 50 times 35 divided by 49 grapes left. And then you can hit math, enter, and you'll get your reduced fraction of 18/35. And that's about 51.4%. And that's all this is all that was right there. All right, let's move on from there. Personally, I think that if you liked green grapes, how many grapes would you eat that were green? Of course, then the chances would be 100%, wouldn't it? This is obviously theoretical if you don't look. This was another one I think is kind of funny because I don't think one of you would do this, but a drawer contains 12 white socks and 8 black socks. You randomly choose one sock and you don't put it back. These are going to be then you randomly choose another sock. What's the probability of both of them are white? Okay, first of all, why would you want to do that? Take the chance, right? But we're going to do the probability of it happening. Here you got 12 plus 8. You have a total of 20 socks. First sock, you got 12 white ones. You're going to have a 12 out of 20 chance of grabbing a white one. Now, you want to be wild that day, and you don't mind if your other sock doesn't match. So you go ahead and you randomly select the next one. But how many white socks do you have left? All right, because one stayed out. How many socks are still in the drawer? 19. Okay, so the numerator and denominator change because these are dependent events. All right, we decided they're dependent by how we just did the problem. They are not independent of one another. All right, I guess we could reduce that. You guys probably did it because you're faster than me. That would be 3. I'm just reducing in my head. Do you have 33 over 95? Good. All right. Try this next one. We got, now we're doing coins. Suppose you flip a coin twice. What's the probability that you get tails on the first flip and tails on the second? Now, does it matter what you flip the first time to see what you get the second time? No, so these are independent events. All right, since they're independent, like you can't change the coin, right? This is quite clearly different. The first flip getting what do we want to get? Tails. 1 in, this is a pretty easy one, times getting a tails on the second flip, 1 in, 2, and we multiply those to get 1 in, 4. And if we wanted a percentage, that'd be 0.25 or 25%. All right, I think we're going to stop there. I want to let you get a moment to get started on looking at worksheets 16 and 17. That's an addition that you'll be working on in the next day or so. So I'm assigning 13 later, tomorrow, which is on the board. Your assignment tonight, though, I want you to look to the page 761, start working on 16 and 17. Be ready with the kind of problems you'd like to have answered in class. And right now, I'll just come around and see if you can't get, so let's go to 16 right now. Because I know you don't have your books, do you? There at home. Pardon?